Dear students, welcome back. So today is the last class of the waves and oscillations, and today we are going to look into the Helmholtz resonator. In this class, we are basically going to see that the air column can be treated as a resonator. That is, the air column will just behave like your spring. So a spring, you are giving certain mass. So if you are giving a certain mass on that, then it is getting compressed, and the moment you are able to lift that mass, then the spring will go up, and therefore the spring is doing a such an down up down up down up, and therefore it is going to vibrate, and therefore we can find out its frequency or the resonant frequency. So the same thing we are going to look into in case of the air column. So that is called the Helmholtz resonator, and we have to do the entire this construction and working, and we have to find out what will be its frequency of the oscillations. So now let us look into the last topic of this, that is Helmholtz resonator. Now let us consider this is your any bottle. So it's maybe made of the brass or the steel or the iron, right? And this bottle, as you you can see in this diagram, so this bottle is empty. So if it is empty, naturally it is filled with the air. So this bottle is filled with the air, right? And here you have got a particular neck of this bottle. So here also you can see you have got a particular neck of this bottle. And now let us just imagine that you are going to put the pressure from this opening, a small opening that we have. You are going to put the pressure. So you can put the pressure with your mouth. So let us suppose you are putting the pressure with your mouth, or you can put certain machine, and with that machine you are pressing the air inside this. So what you can expect, what will happen? So the air which has taken the entire space of this bottle, so it will be getting compressed. So maybe air will be getting compressed up to this value. Let's just example. So let us suppose the air has got compressed, and now the moment we have taken it out, that is we have lifted out our lip, or the machine has been removed. Since this air has already been compressed, so it will like to come back to its original position. So this air will very fastly, since it is very compressed, it will try to come back to original position at its mouth. But because of momentum, some of the air will come out. Some of the air will come out, and it will go to a particular distance. So naturally, if the air is going to come out from this, then what is going to happen? The inside of this bottle, the air volume is going to reduce. So let us suppose if the original volume was V, then its volume will reduce to a lower value, right? So if the volume is getting reduced, so naturally inside the bottle air pressure is also getting reduced. Now what is going to happen? So inside the bottle you will have the rarefication. So some type of the vacuum type of the things is going to be created inside that, right? Because a lot of air has already moved out. So since air has already moved out, so it has some property of the vacuum. So the mouth of your bottle will suck back all those air which has gone out. So it will suck again very fastly. It will suck very fastly, because some type of the rarefication has been produced inside the bottle. And during this process, what will happen? The air inside this will again get compressed, right? So again, if it is getting compressed, so again the moment you are what will happen? So again, because since it has got compressed, so again it will like to come back to its original position, and again because of the momentum it will come out. A lot of air will come out of the bottles. So again you have the vacuum inside that, some type of the vacuum, and then because of the vacuum, again the air molecule will be sucked inside. So in this way the air start vibrating. This vibration will be just like your spring. So what is happening in case of the spring? Here you can see the right hand side of you. Here you have left hand side, you have the spring. So on this spring, let us suppose you have given a mass, and because of this mass, this spring has got compressed, right? And then of course this spring will come back, like to come back to its original position, right? Moment it has gone to the original position, again you will have this stiffness constant of the spring, which will again try to bring back to the original position. But again because of the momentum, it is getting compressed. So in this way, as you understand, the spring will start oscillating. So spring will have a stiffness constant. So similarly here air will have a stiffness constant, and because of that air stiffness constant of the air is going to vibrate inside this chamber, and this is called your Helmholtz resonator. So this is the basically the construction of your Helmholtz resonator. So now let us try to understand that the things that I have written. It is used to analyze the complex note. It consists of a hollow sphere of thin glass or the brass with an opening through a narrow neck. So as you can see, you have got the opening of a very narrow neck. It has got the opening. All right. It is filled with air, of course. When air is pushed into the sphere and released, the pressure will drive it out. So this is what I have explained you. Then what we are saying, the volume of the air in the container behaves as a mass of a spring which is pulled down and released. So naturally the air is going to behave just like your spring. The compressed air tends to move out and create the low pressure inside. So this is what I have explained you. So if the air is getting removed, so if the air from here is coming out more than the original air that was there, so its volume is getting decreased, so therefore inside the pressure is also getting lowered, so it is going to create the low pressure zone, and therefore a lot of air is again going to be sucked back, and because of that again the air inside that is going to be compressed. So compressed air tends to move out and create the low pressure inside. So the vibration is due to the springiness of the air. When you compress it, its pressure increases and it tends to expand back to its original volume. Consider a lump of the air at the neck of the bottle. The air jet can force the lump of air a little down the neck, thereby compressing the air inside. Right? So this is what you are going doing either with your neck, lip, or you are doing with the some compression. So then what is happening? That pressure now drives the lump of air out, but when it get to its original position, its momentum takes its outside the body by a small distance. So the some of the air is coming out of the bottle through that neck, and it is going to move to a small distance above the neck. This rarefies the air inside the body, which then suck the lump of air back. So since the volume inside has got less, right? So because of that, the pressure inside the bottle has got decreased. So somehow you have got some little vacuum as you produce, and then because of that vacuum, the air is again being sucked back, right? And this is how the oscillations is being generated. It can thus vibrate like a mass on a spring. The jet of the air from your lip is capable of deflecting alternately into the bottle and outside, and that provides the power to keep the oscillations going on. So let us suppose if you have taken a bottle, so you give pressure, whatever the strength you have, you give a lot of pressure to this, and then you remove your lip. So inside the bottle, the air will start vibrating, and it will continue its vibration for a certain duration of the time, right? So the air inside that start oscillating, and that also create your Helmholtz resonator. So now let us see, this was the construction of your Helmholtz resonator. Now let us see what will be the working of this. So naturally the working is just like your construction only. What will be the difference? Only here you have to find out what will be the resonant frequency. So what are the factors on which the resonant frequency is dependent? This is what we want to see over here. The air will oscillate into and out of the container at its natural frequency given by the expression resonant frequency F resonance will equal to V, where V is the velocity of your sound, right, upon 2 pi up into under root A upon V into L. Now let us try to understand this. Now let us suppose just I have taken one tap of the bottle. So inside this the volume is V. So this we are calling the volume of the cavity. This is the volume of the cavity. This is the length of the neck, and that length of the neck we have represented by L, right? And this is the area. This is the area of your neck. This is your A, right? So this is the opening through which the air is going and coming. As you can see, it has been indicated by the arrow. So the air is going out from this bottle and it is coming to that small area. So the resonance in this case is directly proportional to, here let us suppose this is your proportionality constant, v upon 2 pi is constant, because v is the velocity of the sound, upon 2 pi is a constant. So F resonance is directly proportional to a square root of the area of your neck. So whatever be the area of the neck, it is directly proportional to that. It is inversely proportional to volume. That is, here this is the volume of the cavity. So volume of the cavity into the length of your neck, right? Into the length of your neck. So what I can say, if the area of your neck is more, then resonance frequency will be more. Because why? If the area is going to be more, the more amount of the air can come out, right? If the volume is going to be more, if the volume of the cavity is going to be more, then resonance is going to be less. Similarly, if the length of this is going to be more, then again the resonance is going to be less, right? So what we are saying, F resonance is directly proportional to under root A upon VL, where proportionally constant is equal to V upon 2 pi, and that is where V is equal to your velocity of sound. So let us see how all these factors that I have taken, how you represent this. So what I am going to tell you, the same the figure I have taken over here. So this is your nothing, this is your volume of the air that you have taken. This is the length of the opening that you have taken. This is your L, and this is the area of cross section of your neck of the bottle. So the resonance is directly proportional to, right, area of your opening port. Why? The large opening gives the higher frequency, since air can rush in and out faster. So if the area is more, the air can rush faster, right? It can go also very fast, it can come inside also very fast. So naturally the resonance, more is the going and coming, that more is the frequency, more will be the value of the resonance. It is inversely proportional to the volume of the cavity. So why we are saying larger volume gives the lower frequency, since more air must move out to relieve a given pressure excess, right? So because of this, the volume, it is inversely proportional to the volume, and length of your neck, again it is inversely proportional. As you can see, longer the neck gives the lower frequency, since there is more resistance of the air moving in and out because of the increase of the resistance. So more resistance of air moving in and out because of your larger length, right? So naturally the more longer distance is going to travel, so the resistance is going to be more, and therefore what you can say, the frequency will be less. So in this way we have finished this Helmholtz resonator. So therefore my friends, I have again finished your SHM completely, that is the waves and oscillations completely I have finished. This we had also done in your regular lectures. Numerical problem right now I am not taking on this chapter, because now we should start the module 5. And so later on, when again I get some time, I will be uploading some more numerical problems that we have already done in the class. And then in between, I will be also uploading the shock wave, which you have done in your class. So now from the next class, I'm going to start the module number 5, and shortly looking forward to see all of you there. Thank you very much for your presence. Thank you very much.